Thank you very much, Evgeny. So yeah, like Evgeny said, today I'm gonna talk about scroll, and it's not a very difficult topic, we have to say, honestly, because everyone uses that, and Flutter is a very well designed framework. We have to say it very clearly. It's a very nicely designed framework. So we have a lot of very useful APIs to handle this particular thing in our applications, and we don't really have to think about how it works under the hood, which might be a problematic thing sometimes, because first of all, we don't have a really good perspective to really appreciate a very good job that the Flutter developers did. And the second thing is that sometimes we have a little bit more out of space requirements for our customers. And I believe that all of us sometimes see some strange ideas of combining those different widgets inside of different widgets, where usually some of those stuff can be done a little bit easier if we only understand slightly better the tools that we have. And this is exactly the purpose of this presentation. So to basically talk about the mechanism that we all know, about stuff that we all know, but maybe to give it a little bit more structure. So expect rather easy talk, so you can relax after the whole day of very difficult and slightly more backhandish talks. Okay, so let's get back to business. First of all, of course, we're gonna So first of all, scrolling is not the easiest task that our mobile frameworks have to perform, because of course everything has to work smoothly. We have a lot of stuff to re-render in every single situation. The user can decide to scroll like mad, and everything has to work as expected. So generally speaking, we can say that the scrolling mechanism should give us, first of all, a way to react on those scrolling events in a nice and very performant way, so we wouldn't see any junk and sloppy frames or whatever. Secondly, we would like to have elasticity inside of this framework, so we can scroll slightly more than just an additional element in the list. We would probably like to have like different elements inside of the list that look totally different. We would like to have some toolbars, some images. We would like to scroll in the different ways. So this API, those abstractions have to be well designed, so we will be able to have possibilities to perform all those tasks. And the third thing is that at least in mobile development with at least few years right now, the ideas for the UIs grew rapidly. So we have like the animated toolbars, we have some additional elements. So generally speaking, we would like to have some way of coordinating behavior of different elements inside of the scrolling between each other. So yeah, that's basically the task that we have behind this mechanism, and it's not the easiest one to achieve. And you can see that, like analyzing how Android, for example, handled that across the years. We've basically started with the simple scroll view, which gave us the possibility to render all the stuff that we would like to display, even if it wouldn't fit the screen, and the possibility to just navigate some sort of the frame over this element to decide what should be visible for the user. We also got slightly later, like we got the list view, but then we got, for example, the recycler view that make it a little bit easier to work with the performance aspect. So those never-ending lists that will be recreated dynamically, and so on. And also a few years ago, we got, for example, the coordinator layout, which gave us possibility to create those foldable toolbars, for example, or generally giving the communication between those elements. But those are the layouts that we would have to combine together. We have to know those tools. Those tools have slightly different APIs and slightly different aspects behind them. So of course it works, and we're used to this, but Flutter actually did it much better, because it was later, so it knew what was wrong. So Flutter generally has one object called scroll view, which is the abstract class that has all those capabilities inside, and this is what we're using in our everyday job usually. So talking about the Flutter way, it's not only that Flutter decided to do it better just because, but also Flutter has slightly different ideas behind how the application should work. So first of all, Flutter would like to have all the ideas for scrolling inside of one widget. So the idea of having scroll view inside of the coordinator view, well, where both of those, so to say, objects would have possibility to have gesture recognition and scrolling, will not actually fit into the Flutter world, where it will mean that those gesture detectors are created in every single way, because it's slightly different idea of how those views are declared. So we would like to have the possibility to have one widget that easily and wraps all those elements connected with the scroll. The second thing is that because of how the rendering idea works, we would like to, for example, remember that everything that we have we're rendering on the screen might be quite heavy if we wouldn't reuse the render objects. Of course, like we're used to recreate many times, rebuild our widgets, but render objects are rather heavy. So there were a lot of elements that Flutter also had to take into consideration. And let's just talk what is the effect of those strides. So we all know that we have a lot of different widgets that we can use, like list view, nested scroll view. They usually serve slightly different ideas. Those are usually those elements that we are using in our code. But the most important stuff is that all of those classes are the ancestors of the scroll view class that I've mentioned before. So what is inside of the scroll view class? What is like those consisting elements of the scrolling mechanism? So first of all, we have the layer of abstraction that handles the interaction, which is the scrollable. Then we have some sort of the environment, so sort of the scaffold that holds and provides the possibility for a scroll to happen, which is the viewport. And we have additional elements that are called slivers, which gave us the API to put some sort of the content for the scrolling elements. And I would like to talk briefly about all of those different abstractions, so the whole thing will be a little bit more structurized. And let's start with the first one, which is scrollable. So scrollable, as we've said, is meant to provide some sort of abstraction layer over the interaction with the user. So scrollable, first of all, generates the gesture detector and takes the information from the user events from the screen and detects if the scrolling gesture actually happened. Then it passes those informations to the object called scroll physics, which is very nice and cozy object that stores the clear information that actually process the information from the blur gesture detection information, that, for example, there was a swipe gesture down or up, and the scroll physics decides how we would like to interpret this idea. So what kind of the idea was behind this kind of the gesture. So with the scroll physics, we can, for example, create those kind of behaviors like we know from the page view. So it's not that we are just ending the scroll, but we are also detecting if we're close enough to the edge of the screen. So we would like to glue it, for example. This is how scroll physics works on that and translates those gestures into understandable let's say, objects for the rest of the scrolling mechanism parts. And so the result of scroll physics is passed to scroll controller, which is the object that gives us the possibility of controlling the scroll, of course. And this is the object that we all know and we are often used in different places. And this scroll controller will propagate informations about what is the input from the user across different elements of the scrolling mechanism, but also give us a possibility to programmatically add some other inputs that we would be interested in. So, for example, to say, okay, user probably didn't say that he would like to scroll here, but I would like to do it programmatically. So this is also why we're using Scrollable. And Scrollable is used inside of the build method, inside of course, scroll view abstraction class. And as you can see, we can usually, it's parameterized with those scroll controller, of course, which is the reference that we can use, the scroll physics, and like the axis direction, and those 4 parameters that are easily overridden. So we can very easily create our own scroll view class, where passing those elements to the constructor, and this is like quite easy to do. And some of the already working classes also give us the possibility to use those elements inside of our constructors. So this is not a problem to override those elements inside of the mechanism as well. The second element, the layer, is of course the viewport, as we've said, so the environment for the scroll. And the viewport is the main responsibility is to create some sort of, as we said, the canvas or the scaffold for laying down particular elements of the scroll and handle the, like, let's say, the environment for rendering them. So the most important element for the viewport is the axis direction. This is the parameter that will decide over all the other elements that we would use inside of our scrolling. And the axis direction is basically up, down, right, left. And it says not only like if the axis is vertical or not, but also tells us about the direction. So this is very important because with this parameter, we can easily change the orientation of the list. So if we would like to have something, for example, localize our applications for the countries where the languages are written in not left to right, but right to left or whatever, we can easily manipulate that with this particular element, for example, which is like one of the use cases in an everyday use. But it's also very cunning for us to make our calculations on later parts of working with the scroll also slightly easier. So we know that the viewport has like the axis, and this is the most important thing, that the viewport lays down all the other elements. But how does viewport knows where to put all those particular slivers? So slivers, but for parts of the scrolling view. So generally speaking, it starts with a very simple idea of having some sort of the reference to the widget and the parameter that says where this widget should be placed initially on the main axis. So we have the reference to the center widget, and this is right now it's like the center, so this is like the one on top. And also we can have the anchor parameter that is usually set default to 0, and that's why we would have this element on the top. But we can easily think about the use case in our everyday situations that we would like to. We of course have a list, but we would like to have some sort of the item like that is in the middle of our list. And we don't want to try to think about some different scroll controllers that will find this position and scroll it. We can easily pass this widget that we're interested in as a center to our viewport, and it will automatically draw it where we would like to have it from the very beginning. So this is also a slightly easier way to use that. One of the last elements of the viewport's responsibility is also to give us the elements that are mentioned for the optimization. So this is basically the cache extend and the cache style, which decides how many elements that are not visible right now across, of course, our main axis direction should be already created in order to have nice and smooth animations. The last thing I would like to say about viewport, and it's probably important to know, is that viewport have two different variants. We have like the viewport typical normal viewport class that is called actually viewport, which by default fills the whole screen. And we also have the variant that is called shrink wrapping viewport, which tries to shrink the content. And as far as I remember, like we're all, of course, aware of the shrink wrap flag that we have in, for example, list view and so on. And this flag is used especially to decide which variant of the viewport should be built inside of our build viewport method inside of our scroll view. So this is exactly the if that we have inside of our method. But other than that, see that it's also very easy to parameterize the scroll view, the build viewport with the center, with the anchor. We can also decide on the cache extend, and of course the axis direction is global for the whole scrolling mechanism. So this is also not that difficult to override those parameters, even with the existing classes like list view, for example. Okay, so we talked about Scrollable and the viewport, which gave us the control over the input and the control over and the environment where we can display something. But let's right now we can talk about those somethings that has to be displayed. And the name for that are slivers that we probably all know. So slivers are used right now, and so Flutter, whenever it's trying to render something on the screen, the rendering process consists of 4 phases. So there's a layout phase, painting, composing, and rastering. But since in the scrolling, the most important part for us is layering down the position of the element, and of course its sizes. So for scrolling part, I would like to focus only on the layout phase. Of course, we can override, we can use particular elements of slivers also in the painting phase or in composing phase as well. But this is not strictly connected with the scrolling itself. So that's why I'm going to talk only about this phase. And in Flutter, the phase of layouting is working as follows. So we have the whole widget tree, and the parent widget is asking the children to give him the size of the children regarding the constraints that parents gave the child. So it's pretty much the question, okay, so how big are you? Those are the constraints. Tell me within those constraints your size, so I can determine my size. So those constraints go down until you reach the leaf. Leaf can determine its size and then passes the layout details to its parent, so the parent can determine its size, and so on and so on and so on. In the simplest and probably the best known case where we are using the render boxes, it's pretty much simple because the constraints are nothing else but maximum and the minimum height. And the size is, of course, height and width. So it's not very complicated. But this particular system will not work extremely well with elements that scroll, especially as we were talking that we would like to give some additional possibilities to communicate between different elements. And Flutter uses exactly the layout phase and this particular protocol called Sliver protocol to pass not only the information about the view only, but also some sort of informations of how this environment around the sliver looks like. So the sliver can also define its behavior regarding this whole situation. And that's why the sliver can, for example, that's why we can achieve the effect of coordinating different slivers across the scrolling mechanism. So this is like additional, so to say, responsibility that the Sliver protocol handles. So right now, I would like to talk about the first element, so the scroll constraints. So those elements that are describing so the object that is describing basically the state of the viewport and the scrollable. So so the Sliver would know where the scrolling is now and what are the additional parameters that the Sliver has to know. So in other words, those input values. So the probably most intuitive idea of how Sliver constraints describe the whole scroll state is by a parameter called scroll offset, which is nothing else but the information how much the particular sliver, the sliver that is currently being processed, that would like to give the values to layout phase, is already scrolled. So the very important information is that if we would consider right now the red sliver, the one on top, the scroll offset of the sliver will be non-zero. But for example, for the yellow widget on the list, the scroll offset is still 0 because it wasn't scrolled of the page. So this is how the scroll offset actually works for us. And the next element is the remaining pane extent. So the scroll constraints tells the widget how much space the sliver can fill in the visible area. So the sliver can decide if you like to fill all this available space or not. And the next element is, of course, the amount of the preceding scroll extent. So the sliver that is proceeding. So it's something like scroll offset for the preceding scroll, and of course the user scroll direction. So the information if the user was scrolling up or down. So, for example, we can use that to draw some additional animations, like something like additional physics to the items trying to react on the bouncing effects or something like that. This is also the information that we can get. And also very important and usually quite tricky one, which is the overlap. So the information if the previous widget decided to invade our space that was initially presented for us and decided to paint over our place for the layout. I would have to explain that a little bit more further when we will talk about sliver geometry, but the idea is that we can decide that sliver always has this remaining pane extent, the idea of how much the viewport decides to give the sliver place for, and the sliver can decide to write a little bit more. And usually this is used by, for example, it's right now used by the sliver toolbar. This is exactly how it's done. So the additional elements for the sliver constraints are, of course, the growth direction and the axis direction, which are giving us the additional ideas from the axis direction to also inform the sliver about, for example, the sorting parameters of the given scroll. Sliver geometry is slightly easier, and this is the element that we can easily override inside of our render sliver object. So first of all, of course, the scroll extent. So the amount of scrolling needed to get from the beginning to the end of the sliver. So the whole, so to say, absolute size, even not in the visible area. Layout extent, which is the idea of which sliver can say that, okay, I would like to take only, I don't know, for example, 100 pixels. But then there's also the pane extent, where sliver will say that, okay, I have the layout for 100 pixels, but I would like to paint over 200 pixels, and this is how the overlap can be created. So the sliver can not only say that, okay, this is the amount of the place that I would like to take, but I'm actually painting a little bit more than that. The paint origin, which is the place on the axis direction, main axis direction, where the paint should start, so we can easily now use this element and override it. So it wouldn't be exactly the same as the one that we get from the scroll controller to, for example, create some sort of parallax effects or different speeds of scrolling. And or different paces of scrolling. So those are like those four, probably the most important elements to describe the sliver geometry. So we can, so definitely at this moment we have the absolute size, declared size, and the actual size, and also the place where the scrolling works for. Those are not the all elements in the sliver geometry, of course, but probably those that are most commonly used and the most important for the initial work with the sliver geometry. Okay, so we talked about different ideas, like how this whole mechanism works, but I would like to talk also a little bit about some very few examples of the real use cases where we could, for example, miss like the easier opportunity to fix an issue without knowing this stuff. So first of all, let's just see this kind of not very common scenario where we have this kind of a scrolling. So for example, first 3 pages should be scrolled like normally, and then we should go into the page view behavior. So I've seen this particular example in the code when I was working in one of the projects, and the solution that was proposed was to build a list view that was consisting of a list view and then a view page, which of course was working. Unfortunately, it was quite buggy because there was a problem of communicating different scrolling and gesture detectors between each other, but after all, it was working fine. But in fact, the solution could be much simpler. Basically by overriding and writing custom scroll physics. I'm not going to show the whole code here. Basically, the example I'm showing you is also based on one of the Medium articles I found. I strongly encourage you to also see that and look at this a little bit more in order to understand those particular elements of the scroll physics much into detail. But generally speaking, it could be achieved much easier by basically creating the list view with the custom scroll physics, where the scroll physics can take the width of the screen from the media context, and then of course we can apply this scroll physics to the view, and override the create ballistic simulation by very simple condition where we are basically checking the position and the velocity, of course, in order to know what we should do with that. That's quite simple example of using it in a slightly different way. And the other example I would like to show is the parallax, where we can also the different elements. Usually parallax is achieved by working with the scroll offset and additionally adding in the runtime, but we can create our own sliver that we'll be adding to the custom scroll view, where the sliver, where basically, of course, it has to override the render rigid object, and inside of the perform layout method that is, of course, used inside of the layout phase, it can easily decide that its paint origin will be slightly different than the offset. So we can use the parallax that will be faster, the scrolling will be faster or slower, using any kind of the factor that we would like to have. Okay, thank you. That's it from my side. Thank you very much for your time, and I hope I didn't exceed. Okay, I'm actually on time. I'm not sure if I have time for the questions, but if there are any, I would like to answer them. So thank you very much,
Rafał. And you know what? This, even though you said that this talk is not a hardcore at all, but I think it is pretty interesting, because slivers and scrolling, it is not that easy part of Flutter.
Yeah.
Not the easiest, I would say.
It's easier, I guess, than what you can get in Android, for example.
Yeah.
Where you have, like right now, you have the coordinator layout, you have motion layout. Suddenly, there are slightly different stuff. So it's not that organized, and still, scrolling is a difficult thing. So the tool don't have to be, it cannot be probably just completely easy. But comparing it to what we have in Android, this is like just day and night.
Yeah, that's